So very welcome to the next presenter. His name is Antti Iho. He's arrived from the Natural Resource Institute in Finland, and he is an environmental economist. The title of his presentation is Governance Responsive to Tightening Environmental Requirements for Hydropower, Finland, Germany, and Sweden.
Okay. Thank you, Emmanuel. Can you hear me? Hello, my name is Antti Iho, Natural Resources Institute, Finland. You told me to stand here, sorry. I have the bad habit of walking around. All policy programs and strategies eventually boil down to concrete incentives and policy instruments faced by economic actors, like firms or individuals. And what I hope to do today is to provide some really simple insights on policies affecting small-scale hydropower plants. And I do this by utilizing 3 countries and selecting instruments done there to make the hydropower plants do something differently. And the insights are really simple. I leave the details to you who are better experts in basically all these areas. Okay, so these are the 3 countries. There are some differences. The biggest hydropower producer is Sweden. But the key difference is actually the number of really small facilities. Each of these small facilities has an impact in the tributaries of the rivers. Those are the capillaries of the ecosystems. That's where things happen in terms of biology. And even though they are small in terms of electricity generation, they can be really influential in terms of ecology. But before we go, I have to introduce one concept that will be needed throughout the presentation. That's the concept of net present value. So a facility or any kind of economic activity that is long-lived is characterized by, and particularly hydropower is characterized by the occurrence of profits. You get profits on a regular basis. Once a year, maybe you can calculate that you get this and that amount of revenues, and then every now and then you have massive investment needs. And to characterize basically the economic viability of such operations, you can discount these streams of benefits or revenues and costs from the future, sum them up, and you get a single number, which is the net present value. It's a really simple metric, and it's used typically for assessing investment opportunities, whether to do this and that or whether to do anything at all. But it can also be used to assess the viability of an existing activity at any point in time. So any economic sector, any industry is composed, unless it's a monopoly, and then there's just one. But we just saw that hydropower sectors in these 3 countries, or any countries, is not like that. You have many plants, and you have operations which differ in their economic viability. That's how it always is. In the equilibrium, you have if there are like no government interventions, no regulations, then you tend to have always the ones who struggle the most. That's how it goes. They are the ones who are on verge of dropping out of the business. The fact that you have negative net present value doesn't mean that at this moment you are making losses, but in the long run it's not economically viable to go on. And if we think of the same industry getting environmental measures that are costly, that are facing every single operator here in the similar manner, we can see that more firms, if we think of hydropower plants, so more hydropower plants are now struggling. And in the long run, they are not economically viable. And actually, it's worth noting that the net present value concept is not limited only to money. You can also put environmental values, other values, if you can monetize them. And then you can use like a social net present value. But here, for simplicity, let's think of this as an economic, pure monetary net present value. So there are things you can do. But this creates the pressure to exit the market. And that's really core concept in economics called creative destruction, or that's the driving force of structural change. Basically, the efficiency of a sector is dependent of this structural change that happens in agriculture and in any business. The ones who are doing worse, they leave, and the ones who stay, they tend to grow. But there's an alternative. So you can also prevent this by simply paying subsidies, particularly for these lowest, least viable firms. So you pay the subsidies for those who struggle, and none of the firms is now economically non-viable. So it's cancelled. However, what you have done in terms of if you think of these as small-scale hydropower plants, what you have actually done is that you have kept unprofitable facilities with ecological negative impacts on life support. And you get very little gains in terms of energy supply and almost none gains in terms of balancing the differences in demand and supply in the overall energy markets. So, and this is actually what characterizes the German system. So German subsidy system for hydropower plants is extremely complicated. This is from the initial, from 2005. The numbers have slightly increased, but this is the best picture I found describing it. It's really complicated. The key point is that particularly for small-scale hydropower, it's quite lucrative. You have to meet certain conditions to get the funding, to get the subsidies. But if you compare it, for instance, to the system price average for the last 15 years, it's higher. The very subsidy is higher than the market price. So this raises questions, of course. And also the payments, the total payments are actually quite high. So the last one, from 2019, it was around 400 million euros. And it's mainly focused on the small ones. It has to be said that the German renewable energy program is really complicated, and it's covering other sectors as well, and hydropower is not getting as much. But maybe the biggest consequence is the disturbing effect on the exit dynamics. So it's preventing the facilities of exiting, at least it's not helping them, unless it's socially optimum, really have all those facilities, unless it's worth all these subsidies to keep them in place. And that's, of course, another question. But is that analysis done actively, or has it just happened? This actually resembles the Finnish agricultural sector. Of all the EU countries, we are most heavily subsidized relatively to our revenue levels in agriculture. And that creates like a vicious circle that you start being dependent on the ones who can negotiate the subsidies and not focusing on the markets at all, and then you start getting this kind of self-supporting system of subsidies, granting subsidies, and continuing to exist. Okay, then, so that was just one example. Subsidies keep you on life support and prevent the structural change. Sweden has, we've heard about the Swedish system, and this is a really comprehensive plan. to meet the environmental standards, to revise all the permits that there are. The net present value concept is quite central. There's much in play, but the net present value is in the core of the compensations paid for the facilities, for the measures, what kind of measures they are, whether they are fish passages. They paid for foregone production, and it's calculated with this tool, online tool Snurran. And there's also an explicit option to exit. The compensation is based on the net present value of the hydropower plant. And the Snurran is really helping also to assess that what would be the nice option. This is a program that explicitly covers the entire range of, if we could set the Swedish hydropower plants on that, let's say, net present value sector in terms of economic viability, then it focuses on all of them. Even on those who might be non-viable and whose net present values are terrible, there's an alternative counting method, alternativregel, which gives you a certain granted amount based on your annual production. And then when you come to mid-sized facilities, then it's up to basically it's court decisions that dictate what's happening, but it's because the removals are always an option. Exit is always an option that will be accepted for the small facilities. So this calculation tool is of a lot of help. And this is an explicit, this is an active choice of looking at this option. There are a few points I'd like to make from this calculation tool, this Snurran. First of all, this is one of the sort of components of it. So the operation and maintenance costs. There's a function that's calculating the operation and maintenance cost, and on the horizontal axis you have the production levels. So you don't have to ask anything of the companies, everything's automatic. But it might be that the operating costs calculated by this Snurran could be systematically higher than they are, and or how they feel that they are, how the operators feel that they are, if they are really, really small. And the reasons are that there are actually differences. If you are like a family-owned hydropower plant, or if you are Vattenfall, you have a bit different operational procedures for what to do when something gets broken. What are the safety procedures, etc. So it's really I've seen quite some operations in these family-run hydropower plants, and it's sure that they are cheap, but they are also really dangerous. Then the other thing is that the value for their own time. It's really hard for me to calculate if I do something, construct something of wood or build something. That what's the value of my time? It's nothing. I do it because I like it, and people tend to have that almost as a hobby. I have a hydropower plant, so it's just whether I just spend spare time or just fix the hydropower plant. So what's the salary for your hourly work? And then it's also the case that the possessing something is more valuable than buying something. It's a famous effect called the endowment effect. We tend to appreciate the stuff that we owe much more than the actual value is that we would be willing to pay for it if we already have it. And if you have a facility, that's more valuable than if you would buy it, even with zero transaction costs. So these reasons, for instance, what would they cause? Is actually an interesting shift that happens if you. This is just a calculation done with 5% interest rate, €45 per megawatt price. That if you have a difference in the anticipated production costs and the Snurran calculated production costs, it might create. So I've picked a number so that you see the discrepancy in the costs of these two alternatives for the fund that is paying for these changes and for the person who is possibly making the change, making the call that this is my choice. And in this case, it turns out that the fish weigh is actually less costly for the facility owner than it is, and for the fund, it would be less costly to decommission and pay for those expenses. And then there's another one. The net present value is quite heavily affected by the timing of the costs, that when do they occur. If we assume that we have an infinite stream of net revenues of 10,000 euros, and then we have big investment every 30 years, then the net present values are actually dramatically different. Even though if you would not discount at all, they would be the same. They would be identical. But if you discount, this makes a big difference. So taking into account the timing is also important. Finland has a different approach. We don't have a comprehensive national program. We've had, let's say, voluntary retirement program for facilities that's been going on for 3 years. There's a 50-50 financing between state and private donors. This is more like an ad hoc program. There's also a calculator assisting these choices. Also calculate net present values a bit differently, but not that much. This is the distribution of the Finnish hydropower sector, and these are the results of these last 3 years. So we see that it's been as intended, mostly small-scale facilities. The negotiations are still going on. Some continue business as usual. We have removal processes, completed removals, and one huge natural bypass that's kind of over-complying quite dramatically. So there's really low activity in the smallest facilities because we don't have any alternative rules. So the program can't pay for unprofitable facilities, and then the most activities are there, and there are many reasons for them. Mainly the uncertainty regarding electricity prices, uncertainty regarding maybe upcoming environmental regulations, and the costs of the environmental measures that they know that they have to take. And then there might be willingness to pay by the locals, say, that they are just simply willing to pay the private share and the ecological benefits are high. There are some good characteristics. There are some strategic incentives here for the firm to sort of bias the cost that because this is based on reporting and negotiating, so you can say that this is more valuable than it actually is. And this should definitely be completed with the comprehensive renewal of licenses, because the program doesn't have a long-term mandate. Anyway, to sum up, the scale of the facilities should be recognized, and we tend to forget these small-scale facilities, which might be really important in terms of ecology, but they are quite often neglected when we think of we let the instruments develop passively. Swedish example is exceptional in that case because it takes these into account. Optimization, we've heard quite many times people talk about optimization. It's good to remember that there's also corner solutions in the optimality. So in the optimal solution, so it might be if it has to be larger than zero, then zero could be the best option to choose. So we should address the exit options explicitly, whether we want to promote them or prevent them, but do it actively, and also to analyze the existing policies that how do they do now? Do they prevent or promote, or are they just neutral with respect to exit? Thank you so much.